The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. Alrighty, so today we're going to go on to section 5.5, which is adding and subtracting polynomials. But before we do that, do you have any questions from yesterday's assignment you'd like to look at right now? Anything, anybody? Alrighty, then we'll go on to section 5.5. Now, what we're going to be doing is adding and or subtracting polynomials, and basically this involves combining like terms. And so let's take a look at that process. Let's say I have 15x squared plus 10x squared. These are like terms in that they are identical with the exception of their coefficients. We've got some x squared plus some other x squared. So how do we combine them? We add their coefficients. So 15x squared plus 10x squared would be 25x squared. Any questions about that example? All right. Let's say we've got the following situation: 17y squared minus 22y minus y squared. Even though all three terms contain the variable y, they are not like terms. The first and the last terms are alike. They both contain y squared. The middle term is just y, or in this case, minus 22y, but y and y squared are not like terms. 17y squared minus 1y squared is 16y squared, and then minus 22y. So not only have we simplified this expression by combining like terms, but it's also written in descending powers of the variable. The term with y squared comes first, and then the term with y comes next. Alrighty, let's say we've got negative 3y squared minus y minus 6y squared plus 7y. So we're going to combine like terms. These terms are alike, and those terms are alike. We're also going to put it in descending powers of the variable y. Negative 3y squared minus 6 more y squared would be negative 9y squared. Negative 1y plus 7y would be plus 6y. So now we've combined like terms, and we've written the expression in descending powers of the variable y. Any questions on this example? All right.
I do have a question.
Yes.
So on the, when you said that combining like terms, you went from negative 3y squared minusing 6y squared. The reason why we got rid of that, that squared by the 6y squared, is it because we already have one on the other side?
See, the reason we got rid of this, is that what you said? Say that part again.
Yes.
Well, let me ask you this. If I've got 3 dogs plus 4 dogs, what have I got?
7
7 what?
dogs.
Right, 7 dogs. So now, did I get rid of this? Not really. It's just that I've got 3 of them plus 4 of them, which is 7 of them.
Oh, I see. Okay.
So minus 3 of those, minus 6 more of those is minus 9 of those. So it's still there. Okay?
Thank you.
You're welcome. All right. Let's say I've got the following: 1/5 x squared minus 3/8 x plus 2/3 x squared plus 1/4 x. So I'm going to combine like terms and write the expression in descending powers of x. However, in order to combine like terms, I'm going to need to add or subtract some fractions. So first of all, these two terms are alike and those two terms are alike. I'm going to rewrite this putting the like terms next to each other. So I've got 1/5 x squared plus 2/3 x squared minus 3/8 x plus 1/4 x. Now, the first two terms are like terms, but to combine them, I have to add their coefficients. But to add 1/5 and 2/3, I need a common denominator. So what is the common denominator of 5 and 3? Anybody? Wouldn't it be?
Would it be 15?
15, right. So what I need to do now is take 1/5 and multiply it by 1, but I'm going to write that 1 as 3/3. So now I get 3/15. So 1/5 x squared equals 3/15 x squared. Any questions how I got there? Next, 2/3 x squared becomes something over 15x squared. I need to multiply 2/3 by 5/5, which gives me 10/15 x squared. So 2/3 becomes 10/15. Now, 3/15 plus 10/15 is 13/15, and that is x squared. Any questions? All right, let's take a look at the next two terms. Minus 3/8 x plus 1/4 x. What's the common denominator, or the least common denominator, excuse me, of 8 and 4?
8.
8, correct. If it ain't broke, don't fix it, so we don't have to do anything to the first one. The second one, we're going to multiply by 2/2 to get 2/8. So 1/4 becomes 2/8. Well, now I've got minus 3/8 x plus 2/8 x, which would be minus 1/8 x. And here we have the polynomial simplified and written in descending powers of x. Again, any questions about the process we just went through? All righty, let's take a look at a problem involving decimals. We've got 1.9 m to the 4th power minus 2.4 m to the 6th power minus 3.7 m to the 4th power plus 2.8 m to the 6th power. So now our like terms would be those two and those two. Putting it in descending powers, I'm going to put m to the 6th in front of m to the 4th. Okay, minus 2.4 plus 2.8 would be what? It'd be a positive 0.4. Okay, any questions there? 1.9 m to the 4th minus 3.7 m to the 4th. So we've got 1.9 minus 3.7. So the process you go through, if you're doing this without a calculator, you say subtracting a number is the same as adding its opposite. Adding two numbers with different signs, you subtract the smaller absolute value from the larger absolute value. We get 1.8, and then attach the sign of the number with the larger absolute value. All that to say that you get minus 1.8 m to the 4th. My guess is that at this point, most of you would just do that on a calculator, and you'd say 1.9 minus 3.8 is negative 1, excuse me, 1.9 minus 3.7 is a negative 1.8. Either way, this would be our final answer. Any questions there? All righty. Now, if we have the following polynomials that we're going to add, 3 q squared minus 5q plus 7 plus the quantity 2q squared plus q minus 12. In order to add or subtract polynomials, we have to get rid of grouping symbols that are grouping them together, okay? So that we can combine like terms. In other words, we can't just go in and say, well, let's put the 3q squared and the 2q squared together and make 5q squared. Sometimes that would work, but not always. So we need to get rid of the grouping symbols first. Now, if there's nothing in front of a set of grouping symbols, that's the same thing as if there's an implied 1 coefficient. And distributing that 1 would be the same thing as just getting rid of the grouping symbols or the parentheses, okay? If there's a plus sign in front of a grouping symbol, that again is the same as saying plus 1 times the grouping symbol. So we get plus whatever's inside, okay? So if we're dealing with addition or no operation in front, basically we're dropping the parentheses. Now we can combine like terms. 3q squared plus 2q squared is 5q squared. Minus 5q plus 1q would be minus 4q. And finally, plus 7 minus 12 would be minus 5. So there is the polynomial, and it's in descending powers. Or you could say it's a trinomial, also in descending powers, or what we also call standard form, that idea of descending powers. Any questions about that one?
So in this, in other words, would be evaluating the expression?
No, technically when we evaluate an expression, they give us numerical values for the variables and we plug those in. What we're doing here, what we'd be doing here, we'd be adding polynomials and simplifying the expression.
Okay.
If it went on to say, let q equal 7, and then we put 7 in for q, that would be evaluating the expression. Okay?
Okay.
Keep those questions coming, though. This is all about getting you to understand what I'm trying to do here. Okay. Let's see here. Let's take this example. 2x squared plus xy plus 3y squared plus the quantity 5x squared minus y squared. So this is basically like the last example. There's nothing in front of the first set of parentheses. There's a plus sign in front of the second set of parentheses. So we're getting rid of the parentheses, combining like terms. 2x squared plus 5x squared is 7x squared. Let's see, then I've got plus xy, and 3y squared minus 1y squared would be plus 2y squared. Now, this is in descending powers in terms of the variable x. We've got x squared, x to the first power, no x's at all. Or I suppose you could shove an x to the 0 power in there and it wouldn't change the value of things. But anyway, so this is in descending powers in terms of a variable, in this case, the variable x. Okay, now, here's where things get a little more complicated. We have the quantity 3a cubed. Excuse me, I did that incorrectly. 3a squared minus 2a plus 4 minus the quantity a squared minus 3a plus 7. The directions say subtract the polynomials. Well, the first polynomial is like the others. There's nothing in front, so we can just rewrite it without the parentheses. But now everything changes because we're subtracting that second trinomial. We need to distribute that subtraction. If we just drop the parentheses, we'll only attach that subtraction to the first term, the a squared, and it needs to get distributed to all three terms inside. So we're going to get minus a squared, minus times a minus would be plus 3a, and then minus times a plus is minus 7. All right, any questions there? So in the process of distributing that subtraction sign, I got rid of the parentheses around the second trinomial. Now I'll combine like terms. Those two terms go together, those two terms go together, and those two terms go together. And I'm combining like terms and doing it in descending powers as I go. 3a squared minus 1a squared is 2a squared. Minus 2a plus 3a is plus 1a. And plus 4 minus 7 is minus 3. I want to point out, it isn't wrong to put the implied 1 in front of the a, but I believe in WebAssign, if you do that, it does mark it wrong. So be careful not to put that implied 1 in front of the a, okay? Like I say, it isn't wrong, and if I looked at it, I wouldn't mark it wrong, but I believe in WebAssign, it doesn't recognize it there. It says, well, that we don't need anything there, so don't put a coefficient there. That 1 is implied. In fact, a is the same thing as 1 times a to the 1 power all over 1. Those things are all implied. They're there if we need them. Okay. Next example. We have the quantity negative 4a cubed plus, or h cubed, excuse me, plus 5h squared plus 15 minus the quantity h cubed minus 15. For instance, I said earlier about don't try and combine like terms within two different groups until you've gotten rid of the grouping symbols. We might look at this and say, oh, 15 minus 15 is 0. But in fact, in the process of getting rid of that second set of parentheses, that 15, that minus 15 is going to become a plus 15 because we're subtracting it. So get rid of the grouping symbols first, okay? So I'm going to get negative 4h cubed plus 5h squared plus 15, then distributing the minus 1, minus h cubed, minus times minus is plus 15. Now, combining like terms, those go together and those go together. Negative 4h cubed minus 1 more h cubed would be negative 5h cubed plus 5h squared, and then 15 plus 15 is plus 30. So we get that result. Okay, let's see here. We've got the quantity 3/8 s to the 8th power minus 3/4 s to the 7th power. That whole thing minus the quantity 1/3 s to the 8th power plus 1/5 s to the 7th power. All right. So there's nothing in front of the first set of parentheses. So we'll just recopy the inside contents without the parentheses grouping symbol. Here we've got to distribute the subtraction. So we're going to get minus 1/3 s to the 8th and minus 1/5 s to the 7th. All right. Next, I'm going to recopy the polynomial, putting the like terms next to each other. So these two go together and these two go together. 3/8 s to the 8th minus 1/3 s to the 8th minus 3/4 s to the 7th minus 1/5 s to the 7th. Now, in order to combine like terms, I need the least common denominator. What's the least common denominator of 8 and 3? Anybody?
24.
Correct. So I've got so many 24ths s to the 8th minus so many 24ths s to the 8th. And let's see here. I'd need to multiply that fraction by 3/3. So I'd get 9 24ths s to the 8th. And then minus 1/3, I'd need to multiply by 8/8, which would give me minus 8 24ths s to the 8th. 9 24ths minus 8 24ths would be 1 24th s to the 8th. Continuing on, what's the least common denominator of 4 and 5?
20.
20. So we get minus so many 20ths s to the 7th minus so many 20ths s to the 7th. We'll need to multiply 3/4 times 5/5. So we get minus 15 20ths s to the 7th. We'll need to multiply 1/5 times 4/4. So we get minus 4 20ths s to the 7th. So minus 15 20ths minus 4 more 20ths would be minus 9. Oops, let's write that down a little bit lower. Would be minus 19 20ths s to the 7th. And there's our final simplified binomial.
I have a question.
Yes.
So if we were to get one of these fractions, and would we have to reduce them, or do we just keep them as is?
If you can, you should always reduce them. Yeah.
Okay.
You always want to reduce a fraction unless it specifically tells you not to. Okay. In the end, after you've combined things, right? Because if you reduce these, what's that?
No, go ahead. I have another question after you're done.
Okay, because if we reduce this initially, we'd be right back to where we started. So it's only after we combine them if we could reduce them. Yeah, what's your question?
So on the negative 15 20ths and 20th, and then the negative 4 20th, would that be considered a positive?
No, because we're not multiplying. Okay.
Okay.
If it was negative 15 20ths times negative 4 20ths, that would be a positive 64 hundredths.
Okay.
But taking away 15 20ths and taking away 4 more 20ths, we're taking away a whole bunch of 20ths. Yeah. Okay.
Okay.
So the operation is what matters. Don't get into a malpractice suit by using the wrong operation. Okay. Let's see here. All right. This says subtract 2x squared minus 2x plus 3 from 3x squared plus 4x plus 5. Now, before we do this problem, let's do a different problem. What if it said subtract 4 from 10? How would you write that just using math symbols and getting rid of the words?
Would it just be like 4 or negative 4 plus 10? I don't know.
Well, and that what you say isn't wrong, but that's not literally what it's saying to do here. It says subtract 4 from 10. So wouldn't
So
you
10 minus 4. Okay.
Exactly. And that's equivalent to negative 4 plus 10. So what you said isn't wrong. It's just not a literal interpretation. But the point is subtract 4 from 10 becomes 10 minus 4, right?
Right.
Okay. This says subtract 2x squared minus 2x plus 3 from 3x squared plus 4x plus 5. So what I'm going to have is 3x squared plus 4x plus 5 minus the quantity 2x squared minus 2x plus 3. And let's go back for a minute and let's get the eraser to work. What if I write that? Is that going to give me the correct situation? No, it's not. Now, granted, I could leave this first set of parentheses off, but if I leave the second set off, I'm only subtracting the 2x squared, and I need to subtract the whole quantity. So I need to group that whole thing under that subtraction operation. Then ultimately, I need to distribute. So I'm subtracting that, and I'm subtracting that, and I'm subtracting that. Okay? Any questions there? So now I've got 1x squared plus 6x plus 2. Let me give you a different example. So I have a box of stuff here, okay? There's like a pair of scissors, a pair of glasses, there's a pen, there's some Scotch tape. If I am going to subtract, if I'm going to take away this whole box of stuff, okay, let's say I went back and and you can't see this very well, but I pulled everything out and laid it all on the table. Wouldn't I take away the scissors, and I would take away the glasses, and I would take away the Scotch tape, and I would take away. So in other words, taking away the whole thing, if I lay out the individual pieces, I'm still taking away each piece. So in effect, I'm distributing that subtraction to the whole quantity. Same thing we're doing here. Subtracting all of this is like subtracting this and subtracting this and subtracting that. Okay, with addition, let's see, we got to go up further. With addition, distributing a +1 doesn't change what's inside the group. It's subtraction that we have to really be careful of. Subtracting all of that, we have to distribute that subtraction to every term. All right, I know I've beat that dead horse enough, but that's a issue that students have. So let's be careful with that. Okay. Now, take a look at this situation. It says subtract 3x squared plus 4x minus 7 from the sum of negative 2x squared minus 7x plus 1 and negative 4x squared plus 8x minus 7. So subtract this from the sum of that and that. What if I had subtract b from the sum of a and c? Wouldn't you write a plus c minus b? Subtract b from the sum of a and c. All right? So subtract 3x squared plus 4x minus 7 from the sum of blah, 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 blah. So I'm going to write this. I'm going to have this plus that minus that. So I'm subtracting this from the sum of those. Okay? Now, the first set of parentheses has nothing in front of it, so I'm going to just bring down the terms from the inside. The second set of parentheses has a plus sign, so that's like distributing a 1, which is still going to give me what's inside. But the third set of parentheses has a subtraction, so I'm going to distribute it and get minus 3x squared minus 4x and plus 7. Now that I've gotten rid of all the grouping symbols, I can combine like terms. Negative 2x squared minus 4 more x squared would be negative 6x squared minus 3 more x squared would be negative 9x squared. Minus 7x plus 8x would be plus 1x. Plus 1x minus 4x would be minus 3x. And finally, 1 minus 7 is minus 6 plus 7, or even this, we could say minus 7 and plus 7 would cancel and we get a plus 1. So there's our final trinomial in descending powers.
Okay, I'm sorry, I have another question.
You don't need to apologize for questions. Did I mention to you folks that I work on commission? So I don't get a salary, I just get paid for every question I answer. So the more questions you ask, the more money I make. So keep them coming. What do you got?
Okay, so would this be the same, because how it says subtract the polynomial from the sum of the next polynomials, wouldn't we have to first add up the 2 and then subtract the first one from the sum of the 2? Does that make sense, or is this just
I see what you're saying. And if we had just individual numbers, if we had subtract 7 from the sum of 10 and 3, we go 10 plus 3 minus 7, right? And then we'd say, oh, that's 13 minus 7, and that's 6. That's kind of what you're thinking?
Yes.
Yeah, and we could do that. We could technically just add these two together first, and there's nothing wrong with that, but by getting rid of the grouping symbols, by distributing the plus and the minus, once we're at this state where we've got a whole string of terms, we can go through and combine them without having to do the first two polynomials first. I don't know if that's making any sense or not.
That makes sense. So it's just essentially we're just skipping that step and just doing it as a whole. And so even if I were to add up the 2 and then subtract the equation from the sum, it would still equal the same thing.
Correct. Yes. You
Okay,
can do it that way. So basically what I'm doing is breaking loose all the corrals, letting all the animals out into the field, wandering loosely, and then collecting them, you know, the whole group, rather than taking this group and putting them together. And then, sorry, I used to live on a farm. So, but yeah, you could do it either way.
Okay, that makes sense. Thank you.
Is anybody uncomfortable with the idea of how I can take this whole string of things and pull ones together that aren't next to each other? Is that bothering anybody? Because I can explain that if you need it. Oh, okay, we'll go on then. Let's see here. I know what I want to do. We're going to add polynomials vertically as opposed to horizontally. Let me explain. Let's say I've got 3x squared plus 4x plus 5 plus 2x squared minus 3x plus 6, okay? So this would be adding them horizontally. I'd have 3x squared plus 4x plus 5 plus 2x squared minus 3x plus 6. So I'm getting rid of the grouping symbols and then combining like terms, 5x squared plus x plus 11, okay? Now, what if instead I wrote it this way? I had 3x squared plus 4x plus 5, and then I had 2x squared minus 3x plus 6. And it says use vertical form to add the polynomials. Okay? So I'm going to add these together. 5 plus 6 is 11, so that's a plus 11. 4x minus 3x would be plus 1x, and 3x squared plus 2x squared would be 5x squared. So we get the same answer. Now, I personally am more comfortable adding them together horizontally. But there are times, in fact, at the end of this chapter, we're going to look at a situation where we're going to be subtracting and adding in this vertical form. So this is just sort of an introduction to get you used to that idea. Are we okay with what happened here?
I think I prefer the vertical form easier just because I can see them all put together.
Good for you. Good for you then. Okay, now let's take this situation where, let's see here. All right, we've got 8c squared minus 4c minus 5. Okay, and then we've got minus negative c squared plus 2c plus 9. Okay, so we're back to the horizontal format. This would be 8c squared minus 4c minus 5. Minus times a minus is plus c squared. Minus times a plus is minus 2c. And minus times a plus is minus 9. Combining like terms, 9c squared minus 6c minus 14. Okay, so far. Now, I want to do one more thing before I go on with that problem. If I've got 7 minus 12, recall that I can change subtraction into addition of the opposite. Are we okay with that idea? Subtracting a number is like adding its opposite. Okay, so going back here and doing this problem vertically, we get 8c squared minus 4c minus 5. Let me find this problem here. And then we've got negative c squared plus 2c plus 9. And we're going to subtract the second polynomial from the first. All right. What we need to do is change it. Oops. Forgot to switch colors there. Not that it matters. This is like having, I'm going to change subtracting a quantity into addition of the opposite. So then I've got what? Plus c squared minus 2c minus 9. Okay. I don't know if you see what happened there. Subtracting was like adding the opposite. Here, I just changed one term, but here I had a whole string of terms I had to change. Let me do that again. So I've got, okay, I keep losing that problem. Here it is. 8c squared minus 4c minus 5. Negative c squared plus 2c plus 9, but we're going to subtract. So we're going to distribute. Subtracting a negative is like adding a positive. Subtracting a positive is like adding a negative, and subtracting a positive is like adding a negative. So basically what I did was I changed subtraction to addition of the opposite. So all the signs inside changed. Instead of minus c squared, it's plus. Instead of plus 2c, it's minus 2c. Instead of plus 9, it's minus 9. I know that gets a little complicated. Now we're going to add them because it's addition. So we get minus 9 minus 6c, 9c squared. Okay. Oh, sorry. I did this incorrectly because I couldn't read that. I read it as a 4. My bad. Can't read my own writing. So this would be minus what? 14. Are you seeing this?
Yes.
You may not like it, but at least you're seeing it. Okay. All right. Now, let's say we've got this situation. We've got two airplanes. Once again, I'm not an artist, maybe a con artist, but that's about it. And here's the wing and okay, whatever. And then we've got this smaller airplane down here. And I'm hoping that I don't have to fly in either one of these. And then it says, let's see here. This distance is 9x minus 15 feet. So the shorter plane is 9x minus 15 feet. The distance from the tip of the shorter plane to the tip of the longer plane is 2x plus 3 feet. It says find the polynomial that represents the length of the larger jet. So what would you do? How would you find what?
Subtract.
Careful. We know this length and we know this extra distance. So how would we find the total length here?
Oh, we would have to add them.
You'd add them, correct. So we've got 9x minus 15 plus 2x plus 3, 9x minus 15 plus 2x plus 3, 11x minus 12 feet. Now, why would I write it this way instead of like that? Because the second way, the units of feet are only on this number. So I need to group the entire number of feet. All right with that? Let's see here. Let's see, I've got two columns. And this first column is, let's see, x squared minus 3x plus 2 feet. Okay. And then we've got this second column. And its height is 5x minus 10 feet. Okay. 5x minus 10 feet. Okay. Find a polynomial that represents the difference in the heights of the two columns. So you're looking to find that distance. How would you find that distance?
Okay, I'm sorry. Did you say we don't have the length to that, to the rest of the, what's left?
Right, the part in the red, we're supposed to find that. In other words, we've got the height of the first column. We've got the height of the second column. It says find a polynomial that represents the difference in the heights of the two columns.
So then I would take the height of the longer one and subtract the length of the smaller one from it.
Yes, correct. Good job. So we're going to have x squared minus 3x plus 2 minus the quantity 5x minus 10. Did I get those copied correctly? Okay, so that would be x squared minus 3x plus 2 minus 5x plus 10, because subtracting a negative. And this would be x squared minus 8x plus 12 feet. Okay. Now, if the columns were stacked one atop the other, it says one atop, who talks like that? To what height would they reach? So if we stack them up, how would we find that height?
We'd add them together.
Correct. So x squared minus 3x plus 2 plus the quantity 5x minus 10, x squared minus 3x plus 2 plus 5x minus 10, x squared plus 2x minus 8 feet. Right. Okay. Well, that's all I have for you today. So for this weekend, for tonight, the homework is section 5.5. I will be back. I will be back at 1:15 today with an office hour. Should you have questions? Otherwise, I'm going to stop the recording here.